This is a video tutorial on GCSE chemistry focusing on atom economy and yield. In this video we will look over atom economy and what this means, and we will also look at how to calculate yield and what is meant by actual yield, theoretical yield and percentage yield. So, in this video tutorial, we will look at how to calculate atom economy, we will look at the difference between actual yield and theoretical yield, and we'll have a look at reaction pathways. Our big question today is what is the percentage yield of ferrous sulfide, which is FeS, if 3 mole of Fe, which is iron, produces 220 grams of ferrous sulfide. The actual yield is 220 grams. Atom economy. In industry, it is absolutely vital that chemists know if an experiment is worth doing. To help them work this out, they use something known as atom economy. What do you think this might mean? Well, atom economy looks at the number of atoms that we get out of a reaction, so our desired product, and compares them to the number of atoms we put in. To calculate it, we use this equation. So the atom economy is equal to the MR of the desired product over the MR of all of the reactants that went in. We then times this by 100 to give us our atom economy. In simple terms, we're effectively looking at the useful stuff that we get out of the reaction, the stuff being whatever the desired product happens to be. So what is the atom economy for making hydrogen from magnesium? Well, first of all, we need to know the equation. The equation for this is as follows. So we have Mg, magnesium, plus 2 hydrochloric acids, HCl, goes to MgCl2 and H2. We're interested in the formation of this hydrogen gas. First of all, we need to work out the MRs. As a recap, this is done by using the relative atomic masses from the periodic table. Magnesium has a relative atomic mass of 24. Hydrogen has a relative atomic mass of 1. And chlorine has a relative atomic mass of 35.5. In order to calculate our atom economy, we first need to work out the MRs of the reactants. For magnesium, this is just 24. For our 2HCl, we take our 35.5 and add 1 to it, making 36.5, and then times this by 2 to make 73. We then add these together to get the relative formula mass of all of the reactants. This gives us an MR for all of the reactants of 97. As our only desired product is hydrogen, we only need to work out the MR of hydrogen. This is 1 times 2, which equals 2. Finally, to calculate our atom economy, we need to take our MR of our desired product, which was 2, and divide it by the MR of all of the reactants, which is 97. And then times this number by 100 in order to calculate our atom economy. This gives us an answer of 2.06%. This is obviously a very low number. This means that the atom economy of this equation is very low. This would suggest that this reaction would not be done in order to create hydrogen. This is because only a small amount of hydrogen is made for a relatively large amount of reactant. This reaction is also making a large amount of waste product, our magnesium chloride, which would be the 97.94% of the reaction. When we're thinking about atom economy, we also need to think about reaction pathways. A reaction pathway is how we get from A to B. Different reaction pathways might have different atom economies. We also need to think about what else companies might want to factor in. The key aspects that all companies will want to factor in is the time it takes to make the product, as well as the cost of the process. The higher the atom economy, the more likely the process is to be done. However, a process with low atom economy might still be used if it is quicker or it is more cost effective. Another similar technique to looking at atom economy is to calculate the yield. Yield tells us how much of something we are going to get, so how much of the desired product. The difference is, instead of looking at the atoms involved, we are now interested in the masses, so we're interested in grams. When we're talking about yield, we need to think of three different yields. The first of these is the actual yield. The actual yield is, not surprisingly, the amount of the product you actually get in the reaction. In the lab, this would be worked out via experimentation. However, in the GCSE exams, actual yield will be given to you. The second type of yield we need to talk about is theoretical yield. The theoretical yield is calculated from the balanced reaction equation, which we looked at in a previous video. This will tell us the maximum amount of mass that could be produced from the known amount of reactant. Finally, we also need to talk about percentage yield. Percentage yield looks at the difference between the actual yield and the theoretical yield and works out a percentage between them. You need to know how to work out percentage yield. Percentage yield is equal to the actual yield, that's the mass of the product that's actually been made, over the maximum theoretical mass of the product, the maximum theoretical yield, times 100 to make it into a percentage. This means that the percentage yield will always be between 0 and 100%. 0% means that no reactants were converted into products, 100% would mean that all of the reactants were turned into products. In industry, similar to atom economy, processes should have as high a percentage yield as possible, as this will reduce waste and therefore reduce costs. It is also important to note that yields are always less than 100%. This is because not all of the reactants will react. Some reactions are reversible, as we will look at in another video. Quite often there are side reactions. Products and reactants might both react with products in the air. And finally, we tend to lose some product when we separate it out from the reaction mixture. Here are two questions that I want you to have a go at. The first one is the percentage yield of ferrous sulfide, FeS, if 3 moles of Fe produces 220 grams of ferrous sulfide. In this, the 220 grams is our actual yield, and you need to work out the theoretical yield, using moles is mass over mR. Secondly, for our challenge question, there are two ways to make ammonia. Calculate the atom economy of each and suggest which is the best method. We have calcium oxide plus ammonium chloride goes to calcium chloride and water and ammonia, or hydrogen and nitrogen goes to ammonia. It is also important to note that in the conversion into an explain everything project for this video, the subscript was lost. As such, NH4, the 4 should be subscript, Cl2, H2 and NH3, and the same on the second one. I want you to have a go at these questions now. So for our big question, we need to start off by looking at the ratio. The ratio of iron to sulfur, or more importantly from iron to iron sulfide, is 1:1. Therefore, 3 moles, which we were given in the question of iron, will produce 3 moles of iron sulfide. Because of this ratio of 3:3, we can work out our mass of ferrous sulfide. To do this, we are going to do our moles times our mR, so working out our mR of ferrous sulfide, times this by 3 will give us 264 grams. We can then work out our percentage yield by taking our actual yield, which is 220 grams, and dividing it by our theoretical yield, which was 264. So we're going to do 220 divided by 264 times 100. This gives us an answer of 83.3%. For our second question, we needed to work out the atom economy. For method 1, this gives us an atom economy of 11.7%. And then in method 2, this gives us an atom economy of 100%, as ammonia is the only product formed. To suggest which is the best method, method 2 is better as it has a higher atom economy. However, as we will look at in a future video, it is also a reversible reaction.